Hi guys, my name is Anu. I'm a director of engineering at Aryaka, one among many actually. But today I hope to walk you through our customer-facing portal called MyAryaka. I will be switching between the browser and the PowerPoint. Okay, so there's a whole bunch that I can show you, but I'd like to start with introducing what the portal is. And Renuka and Nati already talked about a bit of it, which is we have a single pane of glass management console that our customers and our partners can use to manage and monitor the customer service. This lets them do things like set up configuration, monitor regular traffic, set up notifications. So if you don't want to keep looking at MyAryaka, have my notifications show up in my emails. All of that can be controlled in a single portal. That portal will let you onboard and enable SD-WAN, security. You can write simple configuration for each site. You can write scale configuration for your large enterprise. You can collaborate with your teammates as you're working together to set up your organization's policies. You can also monitor and troubleshoot what happened with your network. Okay, so I'm going to go through to the next slide, and this is where we're going to start. So what happens when you onboard your service for the first time with MyAryaka, right? So the MyAryaka UI is broken up into home monitor config status reports for you to easily figure out where you can find content, right? So to start your life with Aryaka, you would land on the config page from where you can then onboard a site. You click Add Site and turn up your service by filling up a fairly easy form that shows up. And like Renuka and Nati mentioned, we are also co-managed, so a customer support team can do this for you, but you could do this by yourself as well. You would fill in information like what type of site are we turning up? Are you going to be shipped a CPE? Do you want to connect in a full mesh fashion to all of your other sites? Right? You can say, I have multiple zones at my local site. I want to set those up. I want BGP at each of my zones. You can configure all of those details right here in a single form. And when you're done, you click Submit. And I'll show you an example site that's fully configured. I'm going to close out. And let's pick our Bangalore location. So here you go. So this is our Bangalore location, which is configured for 100 Mbps subscribe bandwidth, has global connectivity. And the UI kind of breaks apart the customer's configuration into connectivity, security, QoS, DHCP, DNS, and so on. This site's configured for a subset of the config, so not everything shows up in a single shot. But the idea is that each of these various sections will have everything you need, right? So let's say I wanted to go ahead and configure connecting to a third-party vendor. So I would go to this UI, and I would add a connector and specify the connector I'm connecting to and fill up this form. Like what kind of tunnels am I using? Am I using VTI? Am I using GRE? I'll fill up this form and I'll click Submit, and it takes effect right away, right? So to be able to configure connectivity of your site, from the site to our POPs, from our site to other sites, site to a third-party vendor, and also to be able to specify, like, I have 2 ISPs, these are my sizes, and also to be able to say some of my applications are routed one way and some of my applications are routed another way. All of that can be done in this singular portal under the config tab. So I'll show you as an example. I think the last time I was here, I showed you how to write application policies. So from the advanced configuration page, I can create a managed application or create a group of applications from where I can write a policy. So I would go and create a policy like, let's say, adjust the traffic, click edit and say, this policy that I'm writing applies to either one site or a collection of sites. And then I can say, what do I need this application to do? I want this application to if it's sourced from a VPN type of zone, to be permitted. So I can say permit VPN traffic and say, I want to send this traffic directly to the internet. Or I can say, I want to send it to a remote connected site, which is also connected via Aryaka. So I can say, send it to a connected site and say which network to use, because your 2 sites may be connected via Aryaka, may be connected via VPN tunnel over internet. It may be even connected via MPLS, which is terminated on the ANAP. So you can choose all of the various networks that you want participating in this. And you can say, let's say both the networks are available. I prefer one network over the other. So you can have all of these customizations in the same form and continue on, right? So let's just pick a zone and continue. At the same time, in that same policy, I can say, I have a guest network, and if the application is accessed from that same guest network, do not let it go through. So deny guest access in that single form. right? When I'm done, I can click submit and the change will take effect. So I'm going to click submit and the portal will ask you, are you planning to make more changes along the way or are you done? So if you wanted to, you could stage all of your changes together and activate it later. So let's say I'm going to choose to activate later. And what that will do is it will stage my changes for config. So a right side panel shows up and it'll tell you, you have about 24 hours to finish doing the work you're doing, or else support will reach out to you and see if you're stuck. Right? Support will be like, hey, do you need help finishing this configuration? We can help you deploy this change into the network if you're having trouble. Or the customer can always reach out to support and say, I need help to proceed. But either way, it's staged for you and ready to activate anytime they want to. So I'm going to leave that there for now while I run through the rest of the configuration. At the end of the demo, I'll show you how activation works, and it'll be really quick.
Anu, you mentioned that you can do VPN connections to third parties. Could I then make this function like an extranet?
Yeah, you can connect to something, let's say, as an example, a couple of our customers connect to like Azure Virtual WAN and have all of their sites connected to that. And then it's still in the VPN zone that the customer chooses, and it would just be your external net that's still VPN'd.
So do they need to have an Aryaka device on the other side of that to be able to make that connection? Or
No,
is it
they
just
do
like
not.
a standard IPsec VPN?
Standard IPsec.
Standard IPsec.
Yes.
And one question, since you're on this one and I see the routing there, I don't see you configuring any routing protocols or anything. Is that handled in software? Is it opaque to us?
Right.
I mean, are we abstracted away from it?
Some. So let's say at your site, and let me show you what that looks like. At a specific site, you can say if that site is using BGP or if it's using statically advertised route, like statically written routes. So let's go to Bangalore as an example. I'm just going to go to the basic site details, which I used to onboard the site
And
with.
this is like the CPE, right?
This is,
like,
yeah, the CPE. So the thing about Aryaka is if you configure one of your sites to have a specific route, all of the other sites know about the route that you learned from the other site. So the routing table is automatically built out by simply providing the local subnets at one site. So that local subnet can be told to Aryaka using BGP or by statically giving us a list. So in this particular example, the default zone of the site has eBGP configured, right? And then routes are learned via the eBGP exchange. And also, in addition to that, some statically configured local subnets are provided. Once this is known for the specific zone, all of the appropriate connected sites have their routing tables built based on this information. So that's like it's opaque to you. You wouldn't know the fact that routing has propagated through. It just has. All you have to do is look at the status to see, did the BGP session come up? And I'll show you where you can find that. But you can see on MyAryaka that you've configured BGP and it has failed to come up or that it has successfully come up. And you can also see the routing table that BGP propagated to you.
Okay.
Right? And also with the site-to-site topology, you can see what other remote sites have connected to this particular site. So then you can know what other remote sites have learned the routes that you have propagated from this site. Okay. Any questions about onboarding?
I guess one more, just with what you just last said. So, so if I'm bringing up a CPE and I'm adding some networks, and it's advertised, I guess, to Aryaka, and Aryaka's not broadcasting, but advertising out to those other sites. Are they building tunnels back to me? Or are they waiting for, traffic to initiate a tunnel, or what? Okay. Like when you said right there, you can see all the other devices reaching back to me.
Yes.
Does that mean that there's traffic flowing?
Right, good question. So your ANAP device builds a pair of redundant tunnels to the POP.
Okay.
And the POPs have a full mesh with all the other POPs to which your other sites are connected.
Okay.
So if you are only connected via Aryaka's VPN network and no other network, then only those pairs of tunnels to the nearest POP exists. So there are no additional tunnels being built as you bring up new sites.
Understood.
Okay. Now, let's say you did say, I want my CPE or ANAP devices to connect to each other over the internet. Then every time you bring up a new site, then those sites automatically bring up tunnels with each other. Right? If you have devices in the path that would prevent this, support would work with you and say, hey, you might need to open a port or a pair of IP addresses to be able to talk to each other. But the ANAPs would talk to each other automatically. You could also there is a networks page here in MyAryaka where you can control what site pairs build tunnels with each other. So this is called VPN Path Internet, where you can build the topology out. Basically, what you would do is you would create groups of sites that need to either full mesh with each other or do like a spoke hub spoke with each other, and then decide how the groups would talk to each other as well. You could say the groups are distinct, they never talk to each other, or the groups are full meshed, that type of thing. So you get complete control over what that mesh looks like. So I'll show you a couple of, so these, for example, there are 3 site groups. Each group has a collection of sites in them, and then it says, this one has a custom topology, that one has a spoke hub spoke topology. So you can build that out. So only the relevant tunnels come up. By default, we go full mesh. If the customer says, no, I don't want that, then you can customize.
That's very cool. Thank you.
Thanks. Okay. So we talked about how to add a site, how to connect sites using topology as a functionality, how to use apps to control what happens to it. The other thing I can show you is that the AIN app can host a DHCP server. So quickly, I know this is not entirely directly security related, but it helps to see the complete picture of everything the portal can do. So I'm going to scroll down to that same site and go to DHCP and see that I can configure a DHCP service. Right now, the AIN app is configured to do neither. So I can click edit and say, this AIN app can host a DHCP server on some zones and be a DHCP relay on another zone. So once you've segmented the network, you can decide what the AIN app needs to do. So let's say it can say, I can host a local DHCP server for my guest network. So I don't want to send the traffic anywhere else. But let's say for all of my wired, wireless, lab, all of that infrastructure, the DHCP server is elsewhere. It's at another site, so I can relay it. So then I can say for each of my zones, I can configure and say, this zone behaves as a DHCP server. What does my subnets look like? What are my pools looking like? Are there static host assignments? All of that can be done in a single workflow. And at the end, when I click continue and click submit, at this time, because I've staged config, it'll go stage in there. And when I activate, it'll take effect on the CPU right away. And the service is running. Okay? All right. Any questions? Cool. Now I get into the security parts. Okay, so we went with what we call the multi-table approach. When we were doing the investigation early on, as we were building the architecture, we were like, how do people manage this giant table of configs that they write? I want to do antivirus for something. I want to do reputation check for something. I want to write an access list. If it's one table, how easy is it to manage this giant table? I want to write one line of config. I have to read the entire table and figure out where it lives in this giant table. Like I have to keep reordering what I need. So what we did is the multi-table approach. So with the multi-table approach, all you need to know is what you're going to do. If you are worried about, okay, I need to adjust my reputation config, there's one table to configure, and you don't worry about the other tables. If you're writing an access control list, you write your access control list, and again, don't worry about your AV table as an example, right? So what we did is we chained multiple engines to function in a single pass method. So your traffic, as it makes its way through, this is the outbound engine sequencing. As you make your way through left to right, you will encounter these engines in sequence. Now, if you've written, for example, an IP reputation policy, which denies traffic here, then the remaining engines are not going to be processed. It gets dropped right away, right? And let's say IP reputation says the destination's IP reputation is good, then the traffic makes its way down, and then let's say it hits the network access control list where you might have written something like, users belonging to group X cannot access application Y, the access control list will drop your traffic for you. So you get to write custom configs knowing the intention of the config so that you don't have to worry about the giant table. You have many little tables that you can write based on your need. Questions? Okay.
If they're implemented in sequence like that, do you get a performance hit because of that?
No. So when I say it's implemented in sequence, so long as a previous engine does not interrupt and kill your traffic, the other engines continue to see. So it's just a continuous flow of packets through the pipeline, and the first engine that denies the traffic will deny the traffic, but otherwise all other engines see the traffic. So it isn't like the previous engine is buffering till it can make a decision. The packets still make its way through, and the subsequent engines are seeing traffic as the previous engines are still making its decisions. Just the first engine to make the decision to drop will drop the traffic.
Yeah, if I may add, there is actually a performance benefit to doing it. instead of performance hit. And typically, there's a performance hit if you're doing service chaining because there's a multiple encrypt, decrypts, and handoffs. In our case, what she's describing is a single pass architecture where once you take the control of the session or the flow or the packets, you do all these different things in the logical sequence. So the sequence engine is actually logical sequence. It's not like you're traversing different TCP/IP stacks. Normally, in service chaining, you traverse the TCP/IP stack and you do encryption, decryption. Then you come down, then you go to the next one, which causes a performance hit. So in our case, it's exactly the opposite. We are ensuring that it is a single pass architecture with logical sequencing.
And when you talked about having logs per session, all of that would be part of the log that I would get if I wanted to do
A
that?
single log will tell you, if you are a TCP flow, a single log will tell you the LAN side IPS said this was the verdict and this was the action taken. The IP reputation engine will tell you this was the verdict and this was the action taken. So at the flow level, all of the various engines encountered will write to the same log and you'll get one record. Now, let's say you are trying to make a TCP connection, let's say a request to a website, then that's one flow with many HTTP requests against them. So every request is processed differently because it's possible against a website. There could be different resources that all have different verdicts, so you might need different actions taken. So every request is logged because they might have different actions against them, right? But in the sequence that the packet traversed the engines for a specific type of entity, so like it's a flow or a request or a DNS request, there's one log. Okay, and the other thing here is that the engines also sequence, like she said, it's sequenced to have efficiency in the sense that if the IP and its reputation is bad, you drop it early on in the service chain as opposed to later on. So the further you move to the right, more processing needs to happen. So you can see there is a network access control table from where you can bifurcate the traffic and say, I don't need you to do further inspection. This traffic is good to go, versus inspect further versus drop traffic. So there's a three-way control. So at network access control level, you can then say skip SSL interception to do further inspection. So you get to choose at this, so let's say you have banking and finance and you don't want to do SSL decryption, you write a network access control rule to say this traffic is good, permit. Or if it's something else like social media or whatever other category you want to inspect further, you say inspect further, at which point SSL happens. If your HTTPS traffic, SSL decryption happens, and then you get to see the SSL related headers. So you can do things like URL, like the complete URL inspection to figure out, do I block this? Is it belonging to the wrong category? Is the score poor? That type of thing. Yeah? Okay, and that's in the outbound direction. In the inbound direction, because of the way our customers use our service, our inbound engines are different from our outbound ones. On the CPE or on the POP, when traffic arrives from the internet, the first thing that happens is NAT. NAT obviously does protection to make sure that only the right type of traffic is entering into the LAN side space of the device, at which point, again, we'll do IPS, we'll do route checking, we'll do zone crossing, and if the traffic was not meant for the site, we will turn around and send it back to the internet if needed. So all of those engines are in the sequence, and it's slightly different sequence from the inbound direction. Any questions? Okay. Okay, having said that, let me show you what it looks like on MyAryaka to actually configure this. So I'll start with showing you how a customer would set up their security services for a single site, okay? Because while MyAryaka is this one portal, you can configure things at a granular level of configuring things per site, or you can configure them for groups of sites, for parts of your organization that have similar needs. So let's start with security right here. So this is how you configure all of the various security engines for a single site. So everything you saw in the engine sequencing diagram earlier on show up in this list. Okay, so as an example, I'm going to pick one engine, and you can do this with any engine in this list. I'm going to pick the network access control. Each engine has a policy table, and the policy table is read top down. Each policy has a collection of match criteria and one action associated with it. And each table has a curated set of match criteria. So you will find that you can choose what type of traffic to control for each type of table that you're trying to look at. So for example, if you're writing an IP reputation table, you don't really care about things like the domain at that point. Your protection is early on in the service chain, that what you're matching are things like zones and destination IP and networks and things like that, and you don't really care about the fact that the domains are a certain type of match you would do. So each table is designed to have a curated set of match criteria that's relevant to that table. So the table, and we'll explain the template functionality in just a sec, but the table is fully compatible with self-management, so they can click edit, and they can say, this is my ordered list of configuration that's applied. And for each of them, you can open it, and you can see all of the match criteria that's available to this table. And for that specific item, you can edit that policy, you can clone it, you can disable it. So let's say you're not sure, you don't want this config, but I don't want it taking effect on the network, you can disable it, you can delete it, and you can add a row below. So I'll show you what edit looks like. So this is edit. At the very top, you get to describe your policy, you write the action that's relevant to what you want your traffic to do, and then you select the match criteria. So we organize the match criteria as who, what, when, where. So who do you want to block, what do you want to block, where the traffic is bound that you want to block, and when should the blocking effect take place if you're trying to block, right? For each match criteria, you can select if that match is a positive match or a negative match. So you can say IP is this set of IP, or IP is not this set of IP. So let's say as an example, I can select is, and then here I can fill in a list of IP addresses or select a pre-made IP address group that has been made for you. So let's say pick something like that and click add, or I can say is not. And I can do this combination. So across different types of match criteria, it's and. So source IP is something and source port is something. Or if you have multiple selectors inside the source IP, it's an or. So multiple source IP, so IP1 or IP2 or IP3 being source IPs, match and then do this action. So that's one policy.
The lists, how can you import lists? You know, if I have a list of 30,000 IP addresses, you know, I'm migrating from one thing to another.
Right. So there's an
I
asset
wanna
management
I
page.
want to do a bulk import.
Yes, there's an asset management page. You can click add asset, and I'll show you what that looks like, and you can import from a CSV.
Okay.
Yeah.
So, story here. So that import function, is it a one-time deal, or can you
have dynamic lists? So, you know, to be able to say like your SOC has a list of IPs that they're wanting blocked everywhere, and they update that from time to time.
Yeah.
Does that automatically come back in, or do you have to go in and import that?
Right. So today the import is manual. So you click a button, you import a spreadsheet. But we are working on what we call a dynamic asset, where you can publish it somewhere that we can pull it from at regular intervals, and you can say how often you want to. It's coming up very shortly. Okay. I'm going to not save this because this is actual live config, but you can. Actually, I should so you can see what that looks like. Hang on. Sorry. Here, let me.
Bangalore.
Yeah. So I am going to, let's say, just because I know what this is and I'm not going to break anything, I'm going to say destination port is 80 and 443. Okay. Because I wrote this policy yesterday. Continue. Good. So when I've made the change, what it does is it tags it, so you can see what change you made. So let's say I changed 3 policies, and you don't really know what you did. You can come back before you've even saved anything. You can see that it shows up with a little tag. Okay, the little tag will say this policy has changes. If it was a brand new policy, the little mouse over would have said added, so you know what you did. And when you open that, at the very bottom, stuff that you added shows up in green. Stuff that you deleted shows up in red, so you know what the change is, and it'll show you like what you did. So this is before you've even saved a change.
Yeah, and before you save a change, you're just one person doing this administration at the moment. But
Yes.
what if you have multiple people? You know, you have a management team
Yes.
and dispersed across the world. They could be all making changes at once. How do you guys deconflict those kind of changes and demonstrate that someone else is making has a change stage?
Right. So I wish I had someone else in the room do this with me. If I went to click edit that first time, it would say, user X is making change to this entity. Please try again later.
Okay.
So and the good thing is, so I'm going to just save as draft. So what's going to happen is when I save as draft or somebody else working on it, the change is in draft mode, so they know somebody else is making a change. So if you log in or somebody else logs in, you'd know that a change is in progress. But if I haven't saved it yet, edit will be prevented. The entity is locked. So when you go to click this edit button here, and if I already have the edit form launched, then it's going to prevent landing on this form.
Gotcha. Okay.
Good. So let's say I'm going to save as draft. And I'm like, I'm not sure about all of the changes I've made. I want to make more, but I want to come back later. You can do that. It'll stay in this draft state till you're ready to push it out. Or I can call a colleague and say, could you take a look at this change? Now that I've saved as draft, somebody else can come in and make more changes and proceed and go ahead and when they're ready, they can submit the change.
And then do you support scheduled changes? Telling the UI, hey, commit this change or push it out at 10 p.m.
Not yet. We are working on it. That would be nice to have. Not yet.
Okay, thanks.
On the other side, on the co-management side, though, you can call support and say, hey, I've made this change. Can you schedule it for X? You could do that.
How much does that cost?
Nothing. It's a part of your service.
Interesting thing is, because everything is as a service, right? This is actually included.
Good.
I mean, that's like one of the strange things, right? Like the only thing we charge customers for is professional services, but because we are as a service, we have to make sure they are running 24/7, and this is all part of it.
And that's the beauty, right? If you're not sure of a change, you can always have the Aryaka support person on the phone and say, this is what I'm going to do. Is it okay? Did I miss anything? Right?
What is the impact of having done this? The cost is your willingness to get on the phone. 'Cause that's hard for some people. But
No,
yeah.
that's great. That's one of the best answers I've heard. I'm surprised there's not a license for that or something. That's great.
Okay. Good. Any questions about the policy table?
So when you said that it was like you're going to make changes later and it's going to lock out that object, is that at the object level or is that at the service level where nobody can make policy changes?
Just this. So this network access control in this mode, like if I left it in the edit state, like I left this browser open, then this this particular table is locked for edit.
Okay,
The rest of the service is open. You can make other changes.
so if Bob left his laptop on that edit screen for hours, then
That
we're gonna-
object is locked, but you do know that it's Bob, so you can call up Bob and be like, hey,
okay.
what's happening? Are you done? Because you don't want somebody else to make a change that's already in flight, because you don't know what you're messing up. What did that person intend to do? So we did lock it intentionally.
Gotcha.
Okay, good. Ooh, I appear to have zoomed in.
I'm glad you brought back the presentation on this slide, number 21. When you were mentioning the inbound engine, you mentioned the very first one is NAT, and that it was a security feature. Now, Tom, what do you have to feel about NAT?
We've had debates about this internally many times.
Yes, we do.
Yeah, so it
You
is.
said that, and I can't let you get away with it.
No, it is
So
security by.
NAT is not a security feature.
It is security by
That is
obscurity.
an address translation feature that maintains, sometimes, if configured, maintains a state table.
Yes.
But that's not security.
We agree.
And I was also going to say, there's a lot of network architectures that don't use NAT at a boundary, right? They're routing real IP addresses they have from an RIR or IPv6. I get a real allocation that's in my LAN. So then NAT's not there at all.
Yes, correct.
But Tony, since you called me out, I will say this. NAT is a pseudo security feature because if all you've ever done is plumb public networks directly into your environment, NAT will screw you up so bad that nothing will go, which by default is security, right? Because if the traffic can't go anywhere, it's protected. But yeah, it's a commonly misapplied problem. And I love the fact that you're like, did you really say this?
Yeah,
But I mean,
sorry, I put my own foot in my mouth.
no, but the thing is, it's still it's levels of security, right? By natting the traffic, you're hiding the addresses internally. Because remember, we've had this debate with IPv6, right?
We always do, but it's not NAT that's security. It's a state table.
It's a state table.
It's a
that's
state table that
security.
the firewall declares.
Yes,
Right.
agreed.
It's one of those religious debates, like, is it soccer or football?
Yeah.
Okay, because I'm looking at the clock. I took up so much time. Okay, scaling. Let's talk about scaling. So you already saw a sneak peek of it. There are templates. So you don't need to configure this site by site. We have customers with hundreds and thousands of sites, and they don't want to do the site by site. Instead, what they would do is go over to the security tab, discard my changes, and create the templates for the feature you want to configure. So let's pick that same template or same table, and now you can configure templates. Now, templates are themselves organized to help with scaling. I'm going to switch back to my slides just so it's easy for you to kind of picture what I'm trying to say. There are several different types of template. Okay, when your service starts up for the first time, there is a default template at the very, very bottom, as in if you didn't write any config, what happens to the traffic in this table? You can't edit them, but you can supplement and override them. And at the very, very top, there's a system template, which is to have Aryaka service functioning the way you want it to function. You don't want to block Aryaka. So there's stuff at the very top that makes sure that Aryaka services function. Like, for example, our blocking pages, our captive portal pages, those things should not be blocked. So there is a system template at the very top and a default template at the very bottom. Now, you can fill up the middle with whatever you want. Now, the middle can be either individual sites policies for a site, or it can be policies that are learned from templates. Now, there are different types of templates. If your organization wants all of your sites to have a single policy set that is not overridable by anybody, that goes in your global non-overridable template. It's a template applied to every single site. You don't get to choose, and it always sits at the very, very top. Then comes your high priority custom template. Now, it's custom in the sense that you can choose which sites get them, and it's high priority in that it sits right below the global non-overridable one. Which means if you left the global non-overridable template empty, let's say you don't care about one singular template for your entire organization, you create that high priority custom template, let's say for your US, EMEA, and then one for China, and let's say one set for all of the people who are remote. You can create 3 of those templates and apply them to those relevant nodes and sites and have them sit at the very, very top. Nothing overrides a high priority custom template other than the global non-overridable template and the Aryaka system template. That was a lot. Questions?
Yes, one question. Again, with the idea of multiple different administrators, can there be a super admin that can edit or manage some templates, and a tier 2 admin that can only manage or have effect on other layers of the template?
Very good question. That's actually the very next release. 1 week off, it's coming, right? So, right.
3. 3 things coming.
You do this one more time this year, we'll show you more stuff. Okay, then there is the normal priority custom template. So very much like the high priority custom template, you can create custom template or policies that are placed anywhere in the list, which means that you can write site level policies that override the normal priority template. It's basically the ability to give you as much flexibility and scaling as you can possibly want. You don't have to use them if you don't want them. They're just there to help you with ease of use and configuration. Okay, what does it look like on the UI? So I'm just going to go back to security so you can see it. There's a section called security policy templates. For each table, you can configure all of the various templates that you want to. To add a template, you click add, and then you give your name, a description, what type of template you're adding, and you write your policies like you would normally write for the site level, right? When you are done, you will return back here, and oh, I picked hybrid. Okay. Let's try one test. Click add, give it a name, and then go ahead and assign sites to them. And the good thing here is you don't need to actually, sorry, I'm writing blank stuff, but you don't need to assign sites yet. If you're not sure, you can save as draft and return, okay? And talk to your coworkers and figure out what you want. And when you're ready, you can go ahead and assign sites. So I'm gonna click edit and submit for a second so it can let me finish working on this. And then I can say I want to add sites to this. So the good thing about the sites is you don't need to assign them site by site. It's just working through the process. You can create a group of sites that we call site classes and keep them ready for you. So every time you onboard a site, all you have to do is attach it to the right site class. And then that site class is already associated with all the templates, so the configuration takes effect right away. And to configure the assets or the site class as an example, you go to asset management, and here are the list of all of the assets that are ready for you to configure. So you would just go ahead and create a site class and select all of the various sites that need to belong to that site class and name it and be done. And in the future, as you're adding a site, you can say this site belongs to site class X. And then that's just created for you. Okay? All right. It takes care of scaling. Yes. We briefly touched upon this, so how you can save as draft any config and invite a colleague to come collaborate with you on the configuration. And then when you're ready with the the subset of changes that you want to make, click submit. That's one aspect of collaboration. The other one is audit logging. We call it order management because of the co-management aspect. Your entire service can be configured to say, nothing I submit takes effect right away. I'm scared, don't let me make my own network changes or security changes. Please always review my config. So you can have a setting at your organization level to say, all of the things that I submit go via customer support before it hits the network, and customer support eyeballs it before it gets into the network. Or you can say, all of my changes always takes effect right away, right?
So if you're doing the, support spot check everything I do, what kinds of things are they looking for? What are they reviewing against? Because I'm thinking as someone who works for a managed services provider, I don't always know what my customer was thinking. So how does that process?
They will call you. They'll set up a Zoom call and get on a call with you and help you explain to them what you had in mind when you did this. And that will help them get a clear idea about, okay, this is what you meant, and that's indeed what you ended up writing.
Okay.
Yeah. And we'll also tell them things like, did you know that let's say you have this other policy that may be conflicting? Would you like to review this other thing while you're at it? They could do that too. Okay, so here are a list of all of the changes that are submitted by a person. And for that change, you can click that change and see what was done. So this was a new policy that I made. Let me just scroll down, pick something that might actually have a change. Oh, look. These various subnets were added to an IP asset by this person at that time. Okay, and because it's co-managed, it can be done by an Aryaka operator, it can be done by a customer user. If you had a partner manage the service for you, it might be the partner. So you could see who made the change when, and you can see what specific change was made. And this could be for any nature of change. It could be something deleted, something added, something edited. It doesn't matter. You can see it. Okay, I think we're about 5 years worth of history.
Since this is Security Field Day, how do we do the various types of security blocks and things? I'm trying to think from real world examples. I'll get handed a policy, an actual corporate policy that says we need to block some website, or there might be a security threat intelligence feed that we've signed up with as a company that provides us lists of IPs, or a new CVE. And a new CVE maybe needs an IPS rule, or something like that. How can we actually get into that stuff?
Right, let's do it. So the first one you said is I want to block a website. So let's go do actually network access control again. So click edit, click add, and you want to block a specific domain. So domain is www.abc.com. Or you can set a regex, or you can pre-make the assets and add them.
So when you do that, let me stop you right there. Is it doing DNS-based blocks? Is it doing like HTTP matching on the host header in an HTTP traffic? Is it doing an SNI match on the TLS certificate?
Right.
Like, what is it matching on there?
Right. So this particular engine is before SSL decryption. So this is doing the SNI match. So it's not full URL decryption to study it. This is at the level before that. If you wanted to do the DNS domain filtering, there is another engine. So I go back up one level. There is an actual engine called DNS filtering, which there it is. Click add DNS filtering. And then when you in DNS filtering configure www.abc.com to be denied, then the DNS request is being parsed to figure out that's the domain, and then the DNS request is blocked. But if it's network access control, it is the SNI that's being blocked. If you go to the web access control, that's post SSL decryption, so you have full URL access, then it's the HTTPS SSL header that's being evaluated to see, okay, I need to block it because I can read it from there. Similarly, along those same lines, you can say, I want to block a category. So you will come to security, and let's say, I'm going to pick a reputation as an example, and click add, and I can say, I want to block real estate, financial service, I don't know, just bad examples, but you know what I mean, like click and then say drop.
And so for like the domain categories things, I know lots of other vendors outsource that categorization. Do you guys do that in-house, or do you guys also plug into third-party APIs and things?
We use WebRoot.
WebRoot, okay.
Yes. Okay. And the other thing you mentioned was IPS feeds. So I'm going to go back to security so you can kind of see this. We use Proofpoint to provide us the feeds that we use.
Okay.
Signatures.
Yeah, for the
The
signatures,
signatures,
yeah.
yeah.
And then we can write signature templates to say these templates apply to these sites because you might want to have more basic or moderate or advanced protection at individual sites. So you can create templates, and in each template you can say, I want these particular signatures included. It's going to take a minute because the signature set is massive. But you can attach them to a site, and then you can at a site level say, for specific types of site, traffic that's identified using my match criteria, enforce the verdict that's given to us via the third-party vendor, or ignore it and just log. So, or you can even say, don't even do IPS. So you can do skip IPS, enforce, you can do ignore. So you can do all of those things from the IPS control table.
And then like IDS features would be matching, but no enforcement.
Yes,
And
you could do that.
Just a
yes.
matter of maybe ticking a box or something.
Yes.
And then, so if you guys use Proofpoint for that, and if you use WebRoot for that, do all those come from when someone becomes an Aryaka customer, or do we have to add additional
No.
licenses?
Yeah,
Or
they are
anything?
part of the service.
They're part
Part of the
of the
service?
They're part of the
All
service.
inclusive? So it's like one SKU?
One SKU.
All right.
Yes. Well, yeah, we'll talk about it.
base queue and then a few add-ons.
Yes. Okay, let's talk about engine engagement. You wrote a whole bunch of stuff. Does it have any hits? So these are all of the engines right on the UI itself, so you don't have to remember the engine sequence. It's all over, peppered all over the MyAryaka UI, and you can see which engines have the most number of hits. The little red blobs, for some reason it's not showing the measurement, this actually drops. So that engine had 1.029K drops, and you can click it and you can see what engines preceded it, send traffic to this engine, how much did it drop, and what engine saw the traffic next. So on the left dot, it'll say it had like 1.8 million flows that it encountered, out of which 1K were dropped and the remaining went out to the next engine. And you can just navigate the service chain, by the way. You can just click NAC and go to the next engine if you want. Just going to hop back, and you can see what does the drop event range time looks like. Okay, that looks like the window of time. There seems to be 2 spikes. And what was the domain reputation in terms of its distribution? Looks like a lot of it were trustworthy and most of it were permitted. Small aspects were dropped because of various risk profiles. You can hop up one level and you can see time series for the general usage of incoming, outgoing flows, HTTP requests, DNS request and response. You can see the distribution of IP, reputation, health, domain reputation scores. And this particular site does not have its malware protection turned on, so the file health would otherwise show good, bad, unknown. It would show up here. And then for that range of time, you can look at all of the security logs. So the security logs actually let you troubleshoot what has happened. So somebody calls up and says, I'm at IPX and I can't access Facebook. What's going on? You could search for that IP, and you can search for any of the match criteria the end user reported and search for their logs. So as an example, let's just look for all deny logs right here. And wait for it. There you go. So you could see that particular user tried to access that destination at this site and on that port and was denied. You can just preview it quickly and you can see why, like which engine dropped it. That looks like the domain reputation engine dropped it. And all of the other who, what, when, where match criteria is already logged as well. I'm going to click into the detail of that log. So click view, and all of those details show up, including for each engine in the path, what was the verdict, what was the action taken, and so you can see domain reputation said the score was 39, and there's a policy that drops everything below 40, so it dropped it. And the category was web advertisement, right? Further down, what you could do is see what else happened. So this particular flow was a flow that was blocked, not an HTTP request that was blocked. Had I picked an example where an HTTP request was blocked, I could do follow log. What that does is it's kind of like the follow stream in like Wireshark. You can see what else happened to your connection. So let's say you picked one HTTP request that was blocked. It's like saying right click, show me all of the other requests and flows associated with this. So you can see what did the TCP connection encounter, what did all of the other HTTP requests encounter, so you can see the complete list there.
So it's almost like a packet capture type
Like a
feature.
packet capture, yeah.
Pretty cool.
Yes.
Nice.
And because I have 52 seconds left, I'm going to quickly show you home. Home is where you land by default. And when you land here by default, you get a 10,000-foot view of what are my most popular engines? What does the overall IP reputation look like? Who are my bad users? What categories are mostly blocked? What does IPS's verdict looks like for the most part? What sites encounter blocking activities the most, and so on. Okay.
Okay, quick. What about packet captures?
Not yet. It's coming. Four.
Forward. Looks like you know our roadmap.
Yes, you know our roadmap right there. Four.
Do you-
Questions? Yes.
Do you, real quick as well, do you do any pre-change like predictive analytics of like, if I say I'm going to put a block in for facebook.com, this is all the traffic that it's going to block and this is what you've seen?
We don't. That would be cool to add though. We could.
Yeah, but what we can do is we do actually do predictive analytics based on your usage of the network. So that's something that is, I think you might have shown it in the previous
last time.
network field day. So we actually do that that level of predictive analysis.
Okay.
Yeah.